So let's take a look at Unit 5, Lesson 8, Scaling the Outputs. So in 8.2, we're going to skip the 8.1. It's just noticing and wondering about the same picture. In 8.2, we are looking at this bridge in Manchester, England, and it is shaped like a parabola. The ends of the arch are 52 meters apart, and it is 25 meters high. So we're going to use that description to label these coordinates. Okay, so first of all, we know that it is 25 meters high. So the vertex of this parabola is up at 25 units for the y value. We know that this point right here is 0, 0. It's starting at the origin. That helps to make our coordinates a little bit easier. So if we know that it's 52 meters apart, then we know that this x value is 52, and it's going to land again on the ground. So we know that y value is 0. Well, if you remember back from Algebra 1 with our parabolas, this is the vertex, right? And these are the zeros, or x-intercepts, right? And all of the points that cross through a horizontal line on that parabola are equidistant from the center line, right? And so passing through the vertex is that imaginary line called the axis of symmetry. I probably should have picked a different color because that's a little hard to see. I just spelled that wrong. Okay, I'm going to change that color because that's hard to see. Let's try this one. That might be a little better. Axis of symmetry. Right, so our two zeros are the same distance away from that axis of symmetry, right? And so basically the distance between those 2 points is 52. So if we take 52 and divide by 2, we get 26. So we know that that x value at the vertex is 26. All right, so that is how we can get those coordinates. Now let's take a look at Han wants to model the shape of the arch with the graph of a function, and he chooses h of x equals x times 52 minus x, where h of x is the height in meters above a point x meters along the base of the arch from the left end. All right, so for the x coordinates of the 3 points, what are the 3 corresponding points of the graph? So if I plug in 0 into our function, then I'm going to get 0 times 52 minus 0. Well, 0 times anything is 0. So h of 0 is 0. If I plug in 26, then I get 26 times, oops, my brain is thinking ahead of where I am, times 52 minus 26. So that's essentially 26 times 26, which is way bigger than 25. I don't know what that is off the top of my head, so we are going to break out a calculator to help us with that piece. So 26 times 26, that is 25, not 26, there we go, is 676. So that one does not match, but that's okay. And then let's take a look at h of 52. So that gives us 52 times 52 minus 52. Well, that's going to give us 0. All right, so the zeros are fine, but the vertex is a little too high. And that's really the answer to part B. What aspects of the shape does Han's function model well? It fits the zeros. But the vertex is too tall, too high. Okay, so then we're going to look at the height of Hans' graph with the height of the actual bridge. How could we change the outputs of H to make it fit better? What would the revised version of H of X be? Okay, so here's what we're going to do. Using the graphing calculator is so helpful. So we are going to, let's do this. So we'll do H of X is equal to X times 52 minus X. And let's change our window so that it looks more like the window on our picture. So we'll go up to 55. The y-axis goes from 0. We'll go up to 680, since that is what his goes to. So we want to try to change the outputs of H so that it's going to fit better. So y equals, and we want to change the output. We don't want to change the zeros. So we're not going to add or subtract anything from the X value. Or the y value actually, but we want to scale it. So we're going to try multiplying by some things because we don't want to translate it. We want to kind of squash it. So we're going to try multiplying, and to bring it down, we need to multiply by something less than 1, because if we multiply by something greater than 1, it's going to get taller. So let's try 1/2 first. So 0.5 times x to the 52, or times 52 minus x. And that vertex is still really high. So let's try, well, actually, one thing that we could do, if we look at our original vertex, our vertex is at 25. So this vertex is at 25. Has a y value of 25, and his vertex is at 676. So let's see what happens if we multiply his equation by that fraction, 25 divided by 676, because that will get your 676 to cancel out, and you'll be left with 25, so that might be good. And then we can see here, our vertex is 26, 25. Now, it looks a lot more squashed than the one in our actual picture, but that's because of our scale. If we were to take a look at our scale and change that so that it matches the one in our picture, you can see that looks a whole lot more like our picture. It's because we changed that scale so that we could see that other graph there. So it might make more sense to use a model that looks like this, with our 25 divided by 676, and then times x times 52 minus x. And so that would be a good equation to fit the actual equation for the bridge. All right, we're not going to worry about 8.3, but you can take a look at the summary if you want to read a little bit more.